Motion and the laws of motion. Motion involves a change of position of a body with time, which leads to a field of study, kinematics and dynamics. Kinematics tell us how objects move, while dynamics tell us why objects move. Types of motion. Random motion, which is the irregular or disorderly movement of an object. Example is the Brownian movement, that is the motion of a gas particles, smoke particles suspended in air, and various particles in water. Linear motion. This is a type of motion that involves the movement of an object from one point to another in a linear path. Rotational motion is a movement of an object about a fixed point or fixed axis. Circular motion is a movement of an object along the circumference of a cycle or rotation along a circular path. Example is the motion of planets in space. Motion is mathematically described in terms of displacement, distance, velocity, acceleration, speed, and time. Distance is a numerical measurement of how far apart objects or particles are. Displacement is a distance traveled in a specified direction. Speed is the rate of change of distance. Velocity is the rate of change of displacement. Acceleration is the rate of change of velocity. Causes of change in motion. Force. Concept of force. Everyone has a basic understanding of the concept of force from everyday experience. When you push your empty dinner plate away, you exert a force on it. Similarly, you exert a force on a ball when you kick it. In this example, force refers to the interaction with an object by means of muscular activity and some change in velocity of object. Force do not always cause motion. Example, when sitting, gravitational force acts, and yet you are stationary. You can push a building but can't move. Types of force: contact force and field force. Contact force involves physical contact between two objects. Example, push, pull, tension, reaction, and frictional force. Field force. Field force does not involve physical contact. Example, gravitational force between objects, electromagnetic force between electric charges. Laws of motion. Newton's first law of motion, sometimes called the law of inertia, states that an object will continue to be in a state of rest or in uniform motion in a straight line unless acted upon by an external force. In other words, when no force acts on an object, the acceleration of the object is zero. From the first law, we conclude that any isolated object is either at rest and stays at rest or is moving with constant velocity. The ability of an object to resist change in motion is called inertia. First law of motion is not about zero net forces on object, but what happens in the absence of external force. Newton's second law of motion states that the rate of change of momentum is directly proportional to the applied force. Force is proportional to change in momentum over time taken for the change. Change in momentum is equal to mv minus mu. By simplifying mv minus mu, v minus u over t is equal to acceleration, and substituting for acceleration, force is proportional to mass times acceleration. The proportionality constant for this law is k equals to 1, so therefore F equals to ma. Imagine you perform an experiment in which you push a block of mass m across a frictionless horizontal surface. When you exert some horizontal force on the block, it moves with some acceleration. If you double the force on the block, experimental result shows that the acceleration of the block doubles. If you triple force, the acceleration triples. Experiment shows that the greater the mass of an object, the less that object accelerates under the action of a given applied force. Mass is that property of an object that specifies how much resistance an object exhibits to change in its velocity. Note that ma is not a force. All force on an object are added vectorially to generate the net force. Newton's third law of motion. It states that for every action there is equal and opposite reaction. When you press against a corner of a textbook with your fingertip, the book pushes and makes a small dent in your skin. If you push harder, the book does the same and the dent in your skin is little larger. If you hit a wall with your head, the force exerted by your head acts on the wall. At the same time, the wall exerts an equal and opposite force on your head. You will feel this reaction as pain in your head. Same mechanism in jumping. Flying of birds, helicopters, airplanes, and drones.